Question number 15 is about a negligible driver who forgot to engage a brake and left his car on a hill that makes a 24-degree angle below the horizontal. Here's our hill. Here's our car, 24 degrees below horizontal. This hill is 15 meters long. Because of the incline, the car accelerates at 4 meters per second squared for the distance of 50 meters. By the time it gets over here, it has a certain velocity, which is also 24 below. And with that velocity, it's going to fall into the ocean, which is 30 meters below that edge. Two things we need to know: the time in the air and how far the horizontal displacement is. The funny part is they ask for the length of time after they ask for displacement, but we have to find the length of time first before we find displacement. That's the funny part. Anyway, so we're gonna go ahead and do our usual. We're going to separate our x and y. So horizontally we don't know much. Vertically we know g equals 9.8 meters per second squared. Notice that I'm not making it negative because my initial velocity is downward vertically anyway. So this is my v initial y, which I have to find first. I'm going to say my v initial y is going to be the v times sine of 24. Now how do I figure out that v? I know that it travels 50 meters at 4 meters per second squared acceleration. So I'm going to use the v final squared equals v initial squared, which is 0. So that's just non-existent, plus 2 change in x times a. Now mind you, it's not the acceleration due to gravity, it's the acceleration with which the car is going down that incline. So v final is a root of, so it's 50 times 2 times 4 of 400, so that v final right here, that is 20 meters per second. So over here I'm going to say v initial y is 20 sine of 24 degrees. That's 8.13 meters per second. Then I have change in y. That's the formula. I know that my change in y is 30. Again, I don't have to make it negative because I consider downward to be positive. So I have 813 times time, which we need to find, plus 4.9 time squared. You go ahead and graph that. So we have a negative answer, which will not make the cut, and we have 1.78. That is the time that we're going to use. So if change in t is 1.78 seconds, so now to figure out change in x, I need to do vx times that time in the air, which is 1.78, meaning I'm going to do 20 cosine of 24 times 1.78. That's 32.5 meters. Well, there goes the car, unfortunately. Those are the answers to our question number 15. So the time in the air ends up to be 178 seconds. The horizontal distance from the edge of the cliff where the car hits the water is 32.5 meters. There we go.